Live on the internet, welcome. So there's this course information section here, which you guys probably skip right over. You have it minimized in your version. For those of you out there not in the classroom with me, this is that testing information that I emailed you about. So you need to make sure you have somebody that can give you the test that BMCC officially recognizes. Hey Carter, hey Rafael. If you have any questions, just send me an email, give me a call. We got that daily work schedule, which we're relatively on top of. It says we started 3.1 and we're starting 3.2 today, and that is true. I know there's questions on 3.1. We will address them. Anything else interesting there? Not really. I moved the exam to the top, near the top of the page, right? So there's a sample printable exam here. You should definitely look at that. You don't have to do it. It's your life. There's a bunch of review problems. You don't have to do them. It's your life. I would do some of these. I would do some of those. These review problems I took from your homework, pretty much, not all of them, but most of them. And if you have any questions about the print exam, post them to the forum. Somebody asked, am I going to post a complete answer key to the exam? No, I'm not. But if somebody asks for a question to be developed, then an answer to be developed, I will do that, either in video or live or something like that. What's up?
So on the test, will you look over the work that we show and also grade that? Or are you just going to grade it?
No, my philosophy is if all of the questions are right on the test, you get 100%. If there's any part that's the tiniest bit wrong, you get no credit.
Okay.
I'm just kidding. That was a joke. Yeah, so you get partial credit, so you better write down work. So if there's an answer on the paper and there's no supporting work and I can't do it in my head, you get no credit.
Okay, but no, so if the answer's right, but there's no work, are you going to mark us down?
If I can't do it in my head, you get no credit. So here's what you should ask. Could Gary do this in his head?
What if I think you can do it in your
If
head?
you think you can, take a shot, put it down, and maybe you'll get credit.
I will put a note on it and be like, I think you can do this in
So
your head.
if you have any doubt as to whether I can do it in my head, then you better write some evidence down as to why you think that's the answer.
What if you can't do it in your head, but then we can do it in your head, and then we show you how we did it in our head?
You better put that on your page. I'm not going to go sit down with you after and have a little test interview. What did you really mean when you wrote this? That's not going to happen. So be clear. If your work is wrong and your answer is right, you will not get full credit. I look at your work even if the answer is correct. Yeah. What should your work look like? Well, I write work on the board every day in class. Your work should look something like that.
So if our work is right and then we drop like a negative, we get the question wrong, but we get partial credit for doing the work all the way up.
If you have great work and there's a little error, you get most of the credit. So if your error is something to do with like you thought 2 times 3 was 5, right? That's not related to calculus. It's a silly arithmetic mistake. That's a minor error. You might lose a point. If the mistake has to do with you took the limit and you did something that I couldn't conceive of, like you just didn't get the idea of a limit there, that's a major error and you do this a lot more credit, right?
If we factor differently than you.
Well, then it's
We'll talk later, Sam. Chill out. Take a deep breath. All right, let's do some math. So
Chapter 3.
Chapter 3, right? Thank you very much.
Mm-hmm.
All right, so 3.1. I'm going to just write the definition of the derivative down, then we're just going to do a bunch of stuff with it. I had one question for sure on number 5, I think.
3.
And 3, that's the one you posted in the forum?
Yes.
Oh yeah, I looked at your question and I didn't have a problem, so I didn't feel like answering it.
Oh.
I thought
Seriously?
it was easy. I'm kidding. All right, so let's start with, we'll do,
I was going to be really mad at you for a second here.
let's start with number 0. What's the definition of the derivative at a point?
Of the tangent.
Derivative at a point.
Process?
So there's 2 ways to look at it. We've got some function f of x. We've got some x value we're going to call a. So we need to know that there's some y value that we get called f of a. And then what we do is look at a secant by taking some arbitrary distance away, some delta x, some change in x, and we usually call that h. Sometimes you'll see books, and if you look up stuff online, you'll see them use a delta x instead of an a. That's common too. I like h because it's a single symbol. So it is the limit as h approaches 0 of f of a plus h minus f of a all over
You
h.
forgot a parenthesis in the F of A.
Right, look at that. Nice. Nice attention to detail. It's important in calculus. Alternate version of that, if you think about it graphically, you've got this x value right there. You scoot over a little bit to get x plus a. You get these two different y values. Maybe it's sloping up like that. Maybe it's sloping down. You could say this is just some other point b. So another way to look at it is you just want b to get close to a. So alternate definition, which I like sometimes, and I mentioned this last week in class, would be the limit as that b heads over, scoots over to meet up with a and says, hey, how you doing? And it would be f of, oops, that's supposed to be b minus f of a over b minus a. So that's an alternate definition of the derivative at a point. You can use either one.
So would the alternative be better when they give us like the equation?
So it turns out sometimes they're both hard. Sometimes one definition is easier than the other. So I'm going to use both of them today to kind of illustrate that. If you're the kind of person that just likes one way and sticks to it, choose this one and stick with it. Okay. If you like options, I like options, right? Different tools do different things. I like them both. All right, so with that in mind, we're going to scoot away from it for a second and take a look at Sarah's problem.
It's not just my problem.
And see if we can estimate the instantaneous rate of change at x equals 3. So let's see, if x equals 3, I have that point right there. So that looks to be like what? 317. All right, so then what I do is I whip out a ruler and stick it on my screen. So let's see, here's my ruler. Stick that on the screen here. So then I just try and line that ruler up to try and say, okay, what's the slope over there? Is it like this? Is it like that? Is it like right about there?
Seriously?
Yeah.
You just pull the line out of the middle of the midair.
Yes, exactly. So now I just want to find the slope of that line there.
Well, I'm not okay with this concept.
Wait.
Pull the line out there.
What are you trying? So with the line.
I'm trying to estimate the instantaneous rate of change at x equals 3.
Okay,
So that means what's the slope of the tangent line?
How do we know what a
Between-
tangent line looks like?
How do you know what a tangent line looks like?
Yeah, what is it? What is it supposed to do?
Okay, so
Wait,
let's
this was a
do another,
password
chill out.
choice?
Okay, stop.
Isn't it?
Take a deep breath and be quiet. All right. So let's suppose instead we were looking at this point right here. Okay?
Uh-huh.
And then I'm going to just draw another line. Line tool, yep. Let's say this is my line right there. Let's pick it up and move it. Okay, could that be about a tangent line there?
Yeah.
Could this be about a tangent line there?
No.
I pick it up and, oh shit, wrong thing. Not it, there it is. Could that be a tangent line there?
No.
No.
Wait.
Are you capable of taking a piece of paper and holding it up to your screen and estimating what the tangent line is?
I mean, I guess, yeah.
You can totally do that. Innovate. You got this, right? So estimate what you think the tangent line, because the tangent line tells us the instantaneous rate of change. Now, once you have a line, can you find the slope of that line?
Yes.
Yeah, just pick another point on the line. So I think that blue line is my tangent line. And so I'm just going to pick another point that looks good. I like, oh shit. I'm having trouble, technical difficulties. That still kind of lines up, doesn't it?
Yeah.
So I think 2 is a nice number, and if I trace 2 up, it hits about there. If I trace that over, what Y value might that be?
5.
5.5. Take your pick, your life, right? So I'm going to call it 5.5. Order.
2.
X value is 2. Y value is 5.5. Find the slope between those 2 points. That is your estimate of the instantaneous rate of change.
How do
So
they
you
know?
truly do just pull a line out of
Out of the air. Yep, totally.
How do they know? Like you're correct. If you're just
The computer program is set to take answers within like 10%.
Yeah.
They said.
Yeah.
Your estimate needs to be with 10% of the exact answer. How do you know what 10% of the exact answer is? Well, if you're wrong, you're not within 10%. Try again.
Thanks.
Try again. Okay, so I'm just gonna whip that out on the calculator, see if I can get it right today.
I actually have to bring on the computer.
Look at this.
17 minus 5.5 over 1. 11.5 is what I think the instantaneous rate of change is. So then I go back, plug that sucker in. Where'd it go? Here, yeah. 11.5. Did I do a good job pulling a line out of the air today? Ah, I didn't do a good job. So I got to try again, pick another Y value, hope I get it right. If you don't get it right within 3 tries, message me saying, I think one of these is close enough.
Is it 2
And I'll
on
take a
the
look.
test?
What's that?
What on the test?
What about on the test? I hope on paper you can use a ruler and draw relatively accurately on paper.
Oh yeah. You can
It's
see
a
it.
little harder on the screen. So you know what you can do? Anybody have a printer? You could print it and then, try it on a piece of paper with a ruler.
Why would you?
All right, moving along. Next question.
That, when I- it's a little difficult to do edges.
Yes, it's nicer if it's like x equals 1 or x equals 2. I noticed that too. I was thinking about rewriting the problem to not go to the edge. Thank you for that. I will make a note of that. Yeah, but you know what? You get to do it over again. It's not going to take that much time in your life. You'll eventually get it.
Touch screen computer.
I put a ruler on. Mine's touch.
All right.
We're screwed, Ruby. We should print it out.
I'm trying.
Thank you,
I
Skylar,
already
for that
printed it
comment.
out.
All right, this one next. Somebody else in the class emailed me. They weren't sure how to do this. They got the problems before this, but this one threw the loop. A loop? Sure. Let's try it. And I'm going to use both definitions. I'll try it with the first definition. F prime of 5. So I recommended last week a 4-step process to do this. So the first step is to figure out what the heck f of x plus h is. Something that's going to help you get through this week and the next week and pass the exams is anytime you see a function f of x equals, who cares what it is, in your mind you should envision it as f of parentheses equals 2 over parentheses squared. Anytime you see an x, think of an open set of parentheses. Reason being, whatever goes here goes everywhere there was an x in parentheses. Okay, that's practicing safe function stuff. Practice safe function stuff. So in this case, I have a function of 2 over parentheses squared. What do I get to drop inside of the parentheses?
5.
Oh, it's not an x. It's a 5. Thank you, Ms. Miller. 5. It should be a 5 plus h. And then we should do, can we clean that up a little bit? It's up to you. Do you think squaring it will help? Maybe. I'm going to try squaring it. If I square it out, that means I have to take 5 plus h times 5 plus h. That's a 5. Which means I have some distributing to do in the denominator. 25, 5h, 5h, 10h, plus h squared. All right. So that's that sucker written in a slightly different form. Step 2 is to take whatever you got in the previous step and subtract f of 5. So if I plug in 5 here, I think I get 2 over 25.
Yeah.
Okay. So that means I'm going to take this thing over here. And subtract 2 over 25. All right, I should probably act on the subtraction by finding a common denominator. Common denominator is the product of the two denominators.
25h squared plus 250h plus 25 squared.
You get them all. So you could factor this denominator, but that gives you this right there. Does that have a factor of 25? The answer is no. So common denominator here is 25 times 25 plus 10h plus h squared. So what that means here, since I'm multiplying these two together to get a denominator, I need to multiply this numerator by 25 and that numerator by that quadratic. So this gives me 25 times 2 is 50 minus 2 times 25 plus 10h plus h squared. So reaching way back to algebra 2, probably the last time you did something like this. I'm going to have to distribute that negative 2 through here. So I get 50 minus 50, ooh, I love that, minus 20h minus 2h squared, all over that 25 times 25 plus 10h plus h squared, which just, as I'm looking at this and carrying this sucker along, I'm thinking maybe I didn't have to multiply it out, but you never know until you try. All right, numerator cleans up quite a bit, doesn't it? So looking at this, I'm going to need a new page in a sec. 50 minus 50 is 0. That's nice. And then I could factor out of here a negative 2h. I don't know if that helps much, but I can do that. All right, new page. Color. So we are still, let's see, we're on step 2 still?
Yeah.
Oof, tough one. We have, I'm factoring out a negative 2h from that thing, which leaves behind a, what, a 10 plus h all over 25 times 25 plus 10h plus h squared. Does anything cancel? This factors, but it's 5 plus h, not 10 plus h, so that doesn't help. Yeah, I can't do much with this, so I'm on to step 3. Step 3 is to take that difference, 5 plus h minus f5, and divide it by h. Okay, so I need to divide this thing by h. And I can kind of see what happens there. Can you guys see what's going to happen next? Something cancels. So I have negative 2h times 10 plus h over 25 times 25 plus 10h plus h squared. Dividing by h is the same thing as 1 time multiplying by 1 over h. We used that trick last time. So this h right here and that h right there, h divided by h is 1. Those cancel out. So now we are ready to take the limit, step 4. Ooh, that's not bad. Step 4 is the limit as h goes to 0 of whatever's left. So what's left is a negative 2 times 10 plus h over 25 times 25 plus 10h plus h squared. And we have some limit rules that say we can bring the limit to the top and the bottom of the quotient if those limits exist. The only way to find out if they exist is to check. So the only way to check is to plug in h. So if I plug in h in the top, what happens? Well, this sucker goes to 0. That sucker goes to 0. That sucker goes to 0. What do I have left? In the top, negative 2 times 10. In the bottom, 25 times 25? And then I'm just going to clean this up just a little bit by saying 5 goes into 10 twice, 5 goes into 25 5 times. So looks like the slope, the instantaneous rate of change is -4 over 125, a shallow negative slope there. How could I check that? That was a lot of work. I could have totally screwed that up. Look at the graph and see if if at that point when x is 5, if it looks like it has a shallow negative slope. So we'll check this with Desmos. Desmos, there we go. All right, so f of x equals 2 over x squared. Is that what I had? Oh. And then I'm concerned about the points 5 comma f of 5. You see how function notation makes your life easier, right? Once you get used to it, because it's a lot less work. So does it look like a shallow negative slope there? Am I going downhill there? Yeah, okay. And it looks pretty shallow. The question is my shallow slope the right one? So what we're going to do is graph a tangent line and zoom in there and see. So tangent line, easiest way to get one in this case is the point slope form of a line. Point slope line. That means you're given a point, x1, y1. You're given a slope m. The equation is y minus y1 equals m times x minus x1. If you're a TI type person, you have to solve this for y. If you're a Desmos person, you just type it in as is, and it just works beautifully. Let's do it. All right. Tangent line, I think, is y minus, what did we find? It was 2/25 is the y value, equals, we think the slope is -4 over 125.
Yeah.
Move over parentheses x minus 5. Might look all right there. But now I just have to zoom in on that area over there. This is where a TI is nice because you can draw a rectangle around it. So I'm going to have to guess at a configuration. Let's go from 4 to 6, put 5 in the middle. And then we're not very high there.
Wait,
Oh.
is y1 the same as f of 5?
Yes, y1 and f of 5 are the same. So you could type f of 5 right there. No.
Can you scroll?
I could scroll, but I don't feel like being different today. So 0 up to 5 over, let's see, 2 over 25 is 4 times 2 is 8. 800's 0.08, so maybe I'll go up to 0.1-ish. Oh, look at that! Nailed it! Woo! That was hard, wasn't
There
it?
isn't an easier way to do that.
No.
And the key is it can't cross over more than one.
Yeah, so if this line was like slicing through that way, I'd have a problem, right? So I'm looking to see, do the curve and the line seem to be at the same angle at that point? That's what I'm hoping for. All right, let's do it a different way. We're going to use that other version of
Can you
slope.
just type in the fraction?
Oh.
You can just type it, in the homework.
Yeah.
If you click on the box in the homework, it'll tell you how it wants it. It says enter a mathematical expression, which could be -4 over 125, or the decimal version's not too bad. That sucker.
More into those examples.
Yeah, and it gives you other options as an example. So I should just be able to type that in. Nailed it. All right. So we're going to do that again, but this time we're going to use the other definition of the derivative. So the other version is f prime of a is equal to the limit as b goes to a of f of b minus f of a over b minus a. So here, my function is 2 over x squared, and a is 5, b is b. So this is going to be the limits as, let's see, b goes to 5 of f of b, oops, I'll actually write what that is. What happens if I replace x with b? Well, I just get 2 over b squared minus, I'm actually plugging in the 5, so that's 2 over 5 squared. I feel pretty comfortable in my head saying that's 25. All over b minus 5 is what this one says. Hey, that doesn't look too bad. Think of the 2 pages we just generated the other way. Oh, nice. Okay. Common denominator is going to be what? In the top here? 25b squared, yeah. So I need to multiply this guy by b squared, this guy by 25. So my numerator, so I'm going to ignore the limit for a minute, so I don't feel like rewriting it. I'm going to get 50 minus 2b squared over 25b squared. What's another way to divide with fractions? Yeah, so this would be times 1 over b minus 5. Now, if I try to cheat and plug in at this point, the 5, what's 2 times 5 squared? 50. 50 minus 50 is 0. What's 5 minus 5?
0.
I get 0 over 0. So I'm praying this numerator factors. And it does. I can pull a 2 out of the top. That's going to give me 2 times 25 minus b squared. And doesn't 25 minus b squared factor?
Yeah.
Yeah, that factors as 5 minus b times 5 plus b. Oh man, I'm so darn close. Check this out. This is in the denominator. This is in the numerator. How are those two related? 5 minus b and b minus 5? They don't quite cancel. One's the opposite of the other. One's negative, one's positive, right? Think about 10 minus 5 versus 5 minus 10. Yeah, these two things are opposite of each other. So they don't cancel to 1, they cancel to -1. Correct, yeah. All right, so I'm just going to rewrite that over here. Oops. And so what I have is the numerator is 2 times b, 5 minus b, sorry. 5 minus b times 5 plus b over 25b squared times b minus 5. And then the observation we made is that this guy goes into that guy -1 times. So we get a multiple of -1 filled in there because they are opposite value. So what do we have now? We've got -2 times 5 plus b over 25b squared over nothing else. That's it, right? Because we cancel. Is it safe to plug in b equals 5 now?
No.
Yeah, I don't get any zeros. I think I'm safe here. Yeah. All right. So let me copy this to a new screen so I can, wrong tool. Get it all? Yep. So I am taking the limit of that, not too bad of a mess, as b goes to 5. I think it's safe to plug in 5 at this point. So -2 times 5 plus 5 over 25 times 5 squared. So that's -2 times 10 over 25. Wait a minute, this looks familiar. Didn't we see that earlier?
Yeah.
The other way?
Same thing.
Yeah, same thing. We can cancel just a bit here. 5 goes into 10 5 times, or say twice, sorry. 5 goes into 25 5 times, and I get -4 over 125. Was the alternative definition a little bit easier? Yeah. Here's the problem, though. You don't know ahead of time which way is easier until you do them both. And you can say, oh, look at that, the first one was easier. Oops. You don't know. So you have 2 options. You get used to both formulas, or you just pick one and stick with it. And sometimes you just got to do some nasty algebra. Okay? Yeah, Victor?
If you do something like a bowl, so take the x, move it to the top, and subtract 1 from the x, move it to the front.
We'll talk about that in a week or two. Yeah, that's a shortcut that we have to prove first. We haven't proven ourselves to use that.
On the test.
Yeah, you can't use it on the test. You have to use the definition. Yeah, what's up, William?
I think I figured out where mistake actually.
Oh, you had a slight error in there?
Yeah, I factored that to 2 rather than -2.
Oh, okay, so you're off with a sign error in the end? Yeah, and again, a lot of times I'll see that, so I'll think I have a positive slope, I look at the graph's negative, look for a sign error, right? Okay, let's try another one. Let's see, usually at the end they're a little harder. That one's not bad, we'll do it. We've done one like that, 7. Oh yeah, 7's a beautiful one, let's do 7. Okay, so we need to find f prime of 8 and an equation for the tangent line. Cool, because that's how we've been checking ourselves. So new page, screenshot. So on the test, it's going to specifically say find either the instantaneous rate of change, but it's going to say use the limit definition, which means you have to use the first definition or the second definition. You get to pick most of the time. The only time you don't get to pick is when I give you that step, do those 4 steps in order. That means I'm saying use the original version of the definition. I don't know which way is easier, so I'm going to use the traditional definition, which is the limit as h goes to 0 of f of x plus h minus f. Oops, it's not supposed to be an x. What is it supposed to be? 8. Yeah. The only difference, by the way, between section 2 and section 3 is we'll leave the x in and plug in the 8 later. Okay, and we'll do one of those in a minute. Oops, did it again. 8. My brain is dying to move on to section 2, but we'll link it in section 1. So with the original definition, I recommend that 4-step process. So step 1, what the heck is f of 8 plus h? So I should think about this thing right here as a square root of 24 minus parentheses. What goes in the parentheses?
8 plus h.
8 plus h. And most of the time, the parentheses are helpful. If you don't use them, you'll have a problem. I can clean this up a little bit by distributing the subtraction through, and I end up with the square root. 24 minus 8 is what, 16 maybe? Minus h inside the square root. All right, step 2, not much I can do besides that, is to take that, whatever it is, and subtract from it what happens when you plug in 8. So let's see, if I just plug in an 8 here, I get the square root of 16, which is 4. So I get that square root and then minus a 4. Okay, step 3 is to take whatever you had from there and divide it by h. So I'm just going to sneak in and divide by h there. All right. At the moment, if I try to cheat and plug in h equals 0, like jump right to step 4, I'm going to get the square root of 16 minus 4, which is 4 minus 4, which is 0, which is 0 over 0. So, need a trick. We went over a trick for this with limits at least a week ago. Anybody remember the trick, William?
Multiplied by the conjugate.
Multiplied by the conjugate, correct. So new piece of paper, we're not at step 4 yet. Officially, we're going to have to take our square root of 16 minus h, then minus 4, multiply by its conjugate, which would be square root of 16 minus h in the root, and then plus 4. And we have to do the same thing in the denominator. Now, the lovely thing here is when I do the distribution, middle terms are going to vanish because this is going to turn into the difference of 2 squares. So I get the square of the square root, which is 16 minus h, middle terms are gone, I get negative times a positive, which is a negative 16. And in the bottom, I get h times that square root plus 4. Ooh, 16 minus 16, isn't that nice? Negative h over h. H cancels out, leaving a negative 1 behind. So now the question is, am I safe to let h go to 0?
Yes.
Let's see. Oh, I turned that h into a 4 over here. It's an h. Yeah, so now if I let h go to 0, I get negative 1 over the square root of 16 plus 4, which is really 4 plus 4, so it looks like negative 1/8 is the slope there. Okay, plenty of room to mess up here, so we should check. What's the best way to check this?
Yes.
Graphically, make that tangent line. So what's the tangent line going to look like? So let's see, the original function was f of x equals square root of 24 minus x, is that right?
Yeah.
Okay. F of 8 we found is 4. So this is our y1 here. So the tangent is going to be y minus 4 equals negative 1/8 times x minus 8. And the program said the tangent line y equals, so they want me to clean this up and solve for y. Notice they give me the y equals there. Okay, so before I plug in though, I'm going to graph it and check. So whip out your graphing thingy. Let's reset this one. And your graphing thingy is going to be super important on most of the test. So let's see, f of x, sqrt of 24 minus x. I think the tangent line is y minus
Wait, don't you want your
4?
point first?
Yeah.
Oh yeah, I probably should get the point. Thank you. The point is 8, comma f of 8. Whoa, how'd that get up there?
From right there.
Interesting. And 8, comma f of 8. Zoom over there. Okay, so there's the point. Downhill slope, negative 1/8. Could be. Hopefully. So then I have y minus, double check, right? That looks like 4, right? 4 equals negative 1 over 8, scoot out of the denominator, parentheses, x minus 8. Oh, shit.
You didn't put your negative.
Oh, I missed the negative. Oh, good job. Negative. Ooh, I think that looks all right. Yeah. So I'm just going to zoom in by just squeezing vertically around that. So maybe I'll go from y equals 4 to 5. Ooh, maybe that wasn't a good choice. Did I mix that up somehow? Oh, there it is. Yeah. That looks pretty darn tangent. Notice the purple is underneath on both sides. Yeah, not bad. All right, I think we're good. So next I got to solve that for y, so I got to just do a little arithmetic.
Wait, why is it y minus 4?
Because that's the y value here. Right, we're at the point,
okay.
We're at the point 8, 4. Yeah. So distributing the negative 1/8 and then add 4 to the other side. Negative 1/8 x plus 1 plus 4. Looks like the y-intercept is 5, which I remember seeing that on the graph. So that should be what I enter into the computer. No, yes, maybe?
Is that f prime? So that y right there?
No. So this is just a tangent line. What we have is that this number right here, that's f prime of 8, which is the slope of the tangent line at x equals 8. And we think it's negative 1/8. Yeah, so f prime is a calculation of slope of a tangent line. So back to the problem here, they say, what is f prime of 8? That's the slope. That's the negative 1/8 we calculated. And then we use that to find the line that's tangent, negative 1/8 times x plus 5. And then always look to see if it gives you any kind of syntax error out here. Oops, syntax error. Sometimes it's explicit about what the error is. Sometimes it's also overly explicit that your syntax is okay. So pay attention to that. I think I'm good. Yeah, got it. Okay. All right, so I'm gonna just jump. Let's see, let's look at this one right here. This question right here is actually jumping us into section 3.2. The only difference in section 3.2 is instead of plugging in an x value and taking the limit, we try to just leave the x there. And I accidentally did one like that last week, you may remember. So let's do it now. Screen shot. If you're curious about if that last problem would be easier using the other definition, the alternate, the only way to know is to try. So if you have a little free time later today, try it the other way, see if it's easier. You never know till you do it both ways. All right, so I'm going to recommend our multi-step process for this. Now here it just says simplify and expand this. It says don't even worry about the limit at this point. So step 1 would be to find that guy. Step 2 would be to find that difference. Step 3 is divide by h. What's going to be super important to do this is for that first part, you think of the function as f of blank equals 4 times blank squared plus 3 times blank plus 3. Because then you can safely replace x with x plus h. And that's usually where all hell breaks loose. So underneath, I'm going to write f of x plus h must be 4 times parentheses x plus h, square that parentheses, plus 3 times parentheses, just drop in the x plus h, plus 3. And I really want to clean that up before I throw in the f of x. If you watch the related videos that I've linked out to these, the teacher that does those videos, he likes to do this all at once. Some people are fine with that. Depends on how much coffee and sleep I've had. Trick. Remember, this is super important. There is no shortcut for squaring a binomial. You can't say that's x squared plus h squared. You've got to multiply that whole thing by itself. So then that's going to give me 4 times this thing times itself. So I got to do x plus h times x plus h. So that's going to be 4 times x squared plus 2xh. Yeah, and this is a pattern we're going to see over and over again for the next couple of weeks. Plus h squared. I think I can do that right now. So I'm just going to go plus 3x plus 3h, and then plus 3. I guess I need to distribute that 4. So I'm going to get 4x squared plus 8xh plus 4h squared plus 3x plus 3h, 3h plus 3. Like terms, are there any other things with just an x squared?
No.
Nope. Any other things with an xh?
No.
Any h squareds?
No.
No, there's no like terms here. Holy crap. I mean, holy schmoly. Jinkies. Next step, we need to subtract the original function. Well, I'm going to do that by just writing it underneath. I have to get rid of a 4x, right? A 4x squared. I'm doing step 2 right now. What else do I have to get rid of?
3x.
I get to get rid of a 3x, right? Because I have to subtract the whole f of x, and I'm going to get rid of a 3.
Oh, what?
Okay, so this is step 2. And that leaves me with 8xh h plus 4h squared
Plus 3.
plus 3h. Oh my gosh, do you know why that is so exciting? Because of step 4.
You can take out an 8.
Divide out all
Step 4 is I get to take an h out, right? I get to divide everything by h. Oh, sorry, step 3, I can't count.
How did you get those numbers right underneath?
These right here or these right here? These?
Yes.
Yeah, so I'm on step 2, and step 2 says, whatever you got there, subtract f of x from it. And my f of x is this stuff up here. So I need to subtract the 4x squared, I need to subtract the 3x, and I need to subtract the 3. So I just wrote them underneath,
You have a minute.
right? Which, what, I have 1 minute? Oh gosh. All right, we're on our track shoes, we got this. So step 3 is to just divide this whole thing by h, which means each piece of the sum is being divided by h. So I'm going to get an 8x. I'm going to get a plus 4h
And it's 3.
and a plus a 3.
Huh?
And that, oh shoot, and that is the answer right there.
It is.
Yeah, because it said just expand and simplify. Expand means do all this stuff, simplify. Yeah, it didn't say actually take the limit.
Can we just skip to step 4?
I don't think this problem doesn't ask for it. That's in the
Yeah,
next
that's
section.
limit.
So right now I'm just gonna enter that in. Can somebody remind me what it was? 8x
plus
4h plus 3. Okay. Now,
I hate that.
oh, that wiggle there, yeah. That's because it's checking the syntax as it goes. Now, section 3.2 would take it a step further and say, now take the limit of that. So I come on my time, but just real quick. 8x plus 4h plus 3. If h goes to 0, what is this?
8x.
Yeah. And what we get here now, this right here is what we call f prime of x. It is a slope function. So now if somebody says, what's the slope at x equals 8? Just plug in x equals 8. What's the slope at -2? Plug in -2. And this just outputs slopes all day long.
That would check for 8.
You could use, yeah, so you could use this idea from 3.2 to check any of your work in 3.1. Yeah. We'll do more with this tomorrow.
Yeah.
The long way is where the short way comes from.
I know.
We'll get there next week.
Still sucks.
Yeah.
That totally made it.
Uh-oh, what happened to my pen?
I
Oh,
hate
there it is.
it.
I was
It's so boring.
All right, more later.